I'm Gavia Gray. I work as a member of the technical staff in the ML core group. We focus on like pre-training, um, large language models, that kind of thing. I'm presenting a pretty technical paper. It was solving like a very specific problem that we had when we're training deep models. Specifically, you want to choose what batch size to use, but you can't test it on smaller models. You have to use it on, you have to test at large scale typically, and that'd be really expensive. So we developed a way to do that based on some prior work at OpenAI, but adapting it to work on our hardware better than on a massive GPU server farm. At a very high level, it's a way to look at the gradients, which are just like the signals that you use to update your neural network. You're trying to figure out where the signal and the noise are in those gradients and figure out how much of it is noise and how much of it is signal. And that tells you how big you want your batch size to be, because as you make your batch size bigger, you can average more of those gradients, and that gives you like more signal. I think it's a really important problem for pre-training efficiency, so you need to know what batch size to use. But in a more kind of general way, it's a really useful metric, and up until now, it was very difficult to measure it. And the only time you could ever measure it was when you were running a massive training run on like hundreds of GPUs. Whereas we've made it now so you can run it on your laptop, or you can run it on a CS2 or anything like. So yeah, I think it's exciting. We're kind of focused and excited on the same thing a lot of people are at the moment, which is just like eliminating hyperparameter tuning. I think there's a lot of stuff we do in deep learning which depends on doing these big hyperparameter tuning runs, which are really expensive, and you don't do that in like other optimization works. Like in like traditional gradient-based optimization, that's basically solved. You just set it to the computer running and it does it. And we need to be able to do that with deep learning. It's kind of ridiculous how we use grad student descent. We can't do that anymore.